This is lesson 0-3, page 9 of the pre-calculus textbook. This lesson is on quadratic functions and equations. We are going to graph quadratic functions. In a quadratic function, the graph is a parabola, either a valley-looking graph or a mountain-looking graph. So the first thing we're going to do is graph the quadratic function using a table. So if we have the function f of x equals 2x squared minus 8x plus 4, we're going to put that information into a table and plug in values for our x to find our f of x or y value. And remember, function is written as f open parentheses x close parentheses. Okay, so I have a table. This is on page P9, step 1, where the header row is the value we're going to put in for x. Then the next column is our function, f of x equals 2x squared minus 8x plus 4. Third column is the f of x, which is our y value. And the last column is our ordered pair, open paren x comma f of x close paren. And those are the ordered pairs that we're going to graph. Okay, so the first thing we need to do is find numbers to put in for, values to put in for our x. So I chose 0, 1, 2, 3, and 4, and same as the book, for our x values, and that's down the first column of our table. So then we put in that 0 for every place you see an x. So I first have f open paren 0 closed, which is f of 0 equals 2 open paren 0 close paren squared minus 8 open 0 closed plus 4. And then we solve for this, and then we get our f of x value, which is 4. So our ordered pair is open 0, comma 4 close. And so now we have our first ordered pair. And then the next value we chose was 1. So we put in a 1 for our x value. So f of 1 equals 2 times 1 squared minus 8 times 1 plus 4. And when we solve, we get an answer for our f of x of -2. So our ordered pair is open 1, comma -2 close. Third value, we put in a 2 for our x value. So we have f of 2 equals 2 times, or 2 open, 2 closed squared minus 8 open, 2 closed plus 4. So this time we need to make sure we square that 2 before we multiply it to the to our first term. So we get a f of x value of -4. So now we have our ordered pair at open 2, comma -4 close. F of 3. So then we have 3 open 3, 2 open 3 closed squared minus 8 open 3 closed plus 4. So our f of x value is -2. So now our ordered pair is open 3, comma -2 closed. And last but not least, we have our x value at 4. So we have f of 4 equals 2 open 4 closed squared minus 8 open 4 close plus 4. So our f of x value is 4. So our ordered pair is open 4, comma 4. So now we have these values, we have these ordered pairs, we have 5 of them. So now let's put them on a graph. Okay, so we have a graph now. And this graph, we need to plot these ordered pairs. So we found the ordered pairs of 0, comma 4. We have 1, comma -2. We have 2 comma negative 4. We have 3 comma negative 2. And then lastly, we have the ordered pair of 4, 4. Okay, so we're going to put these on our graph. So 0, 4, 0 over from the origin, 4 up, plot a point. 1, negative 2, so 1 to the right, down negative 2, plot a point. And the next one we have is 2, negative 4, so over 2, 1, 2, down negative 4. Okay, now for our 3, negative 2, right 3, down 2 to negative 2, plot a point. And then we have the last point of 4, 4. So we move right 4 from the origin, up 4. Okay, and then we connect the dots. So from 0, 4, a line down to our negative 1, 2, down to our 2, negative 4, back up to our, so then we go back up to our 3, negative 2, and then all the way back to our 4, 4. And what you see is a parabola that is opening upward. All right, so that's our parabola. Next thing we're going to talk about is the axis of symmetry. So if we have a parabola, all right, we're still on page P9, and we're going to talk about the axis of symmetry. The axis of symmetry is a line that divides the parabola into two halves that are reflections of each other. So that means you could take a parabola, fold it in half, and each side would match. All right, so that makes it symmetric. It's symmetric about the line of symmetry. So if we have a parabola and we draw a line down the middle and we can fold it in half, so from that axis of symmetry, a perpendicular line that goes through it will be the same distance from the parabola to the axis of symmetry on either side. So that is the axis of symmetry. So now let's talk about the vertex. The vertex is the point where the axis of symmetry touches the parabola. So this is right where the axis of symmetry touches the parabola. It is also in an upward opening parabola, it is the lowest point. And a downward opening parabola, it is the top of the parabola where it continues its journey back down. So that is the vertex. Okay, so now let's talk more about this. If we have an axis of symmetry, a y-intercept, and a vertex, this is all on page P10. So looking at a function, so if we have a function that is f of x equals x squared plus 2x minus 3. Let's find the axis of symmetry, y-intercept, and vertex to graph this function. So the first thing we need to do is determine the a, b, and c. So if you remember, f of x equals ax squared plus bx plus c, where a is the coefficient, b is a coefficient, and c is a coefficient. So we need to determine our a, b, and c. So in our function x squared plus 2x minus 3, we look for the coefficients of each of our terms. So our first term is x squared. So that has a coefficient of 1. So we say a equals 1. Now looking at our second term, which is the bx term, our b value is 2 because we have 2x. And our c value is a negative 3. Because remember that negative sign goes with your number. So we have determined the A, B, and C values for our function. A equals 1, B equals 2, and C equals -3. Okay, so there's an equation where we can find the axis of symmetry, and that equation is x equals the fraction -b over 2a. So we find the a, the b, and the c that we determined from our function and plug it into this equation. So x equals, the numerator would be the opposite of b, and we said b was 2. So we'd have a numerator of -2 over 2 times our a value. And a we said is 1. So 2 times 1. So x equals -2 over 2. So x equals -1. So what does that actually mean? So we have the axis of symmetry is located at -1. So that means on our graph that if we go over to -1, so that's 1 left from the origin to -1, that line, vertical line, is our axis of symmetry of this parabola. Okay, so now we know the axis of symmetry, but where is our vertex? Where does our vertex fall? So we then put in that -1 into our original function in order to find what our vertex is. So for our vertex, we have f of -1 equals -1 squared plus 2 times -1 minus 3. And then we solve. So f of -1 equals -4. So we know the x value is at -1. So of our ordered pair where the vertex is -1. And we just figured out that the f of x, or the y value, is -4. So we can say that our vertex is at -1, 4. So we go -1 on the graph and down to -4. And that is our vertex. So that is the lowest point of this graph. Okay, so now we find the y-intercept and its reflection. Okay, y-intercept. So that is where we want our x to be 0 so we can find our y. So again, we put it into our original function. So we have f of 0 equals 0 squared plus 2 times 0 minus 3. Okay, so we now have a point at 0, -3, which is our y-intercept. Okay, so then we can plot that. So 0 over down to -3. Okay, so now we have 2 points on our graph. We have -1, -4, and we have 0, -3. So now we need to find the reflection of our y-intercept, which is going to be on the left side of our axis of symmetry because the y-intercept is on the right side of the axis of symmetry. So the way we do that is we look how far over is our axis of our y-intercept from the axis of symmetry. So what we need to do is, so we can see that the distance between the axis of symmetry and the y-intercept on the x value is a distance of 1. So we go from -1 to 0. So we hop 1 to the right to get to the y-intercept. So from the axis of symmetry, we go one to the left to find where that reflection point is. So that would be located at -2, comma, -3. And we want the y value to stay the same because we want that same distance in our y value as our y-intercept. We just need to know where it falls on the x-axis. So our second point is the reflection is at -2, -3. So then we can plot that. So we go down -2 and 2. So we go left 2, down 3. And then we have 3 points. So from there, we're able to draw our parabola. Okay, so this is maximum and minimum values. We are on page P10, down at the bottom. So if we have a graph that is upward opening, so the parabola opens upward, we call that a minimum because the vertex, the lowest point where it turns the corner and starts heading back up, is the lowest point on the graph. So this is called a minimum. Now, if we have a downward opening graph, our values increase to a point on the x-axis and then start to decrease. So this is called a maximum. So with a minimum, we have a low value, then it goes back up, and a maximum, we have a high value, and then it goes back down. And the way we can determine that is if we have a function, we have f of x equals ax squared plus bx plus c, we look at our a value. And if our a value is greater than 0, if our a value is greater than 0, then that is a minimum. And if we have an a value that is less than 0, then we have a maximum. So we can determine right away whether or not our graph is going to be upward opening or downward opening based on the value of the a term. Okay, so if we want to look and see what minimum and maximum values are, we can easily do that. So what we need to do is look at our function. So if I was to give you the function f of x, and this is on the top of page P11, f of x equals -3x squared plus 12x plus 11. So the first thing we need to do is determine whether it's a minimum or maximum value. So we look at our a term. We have -3x squared. So our a is less than 0. So this is a maximum because our a value is -3. Okay, so we know this is a maximum, so we are going to have a downward opening parabola. But where is that maximum value? The way we can do that is we look at the equation for axis of symmetry. So which is x equals the fraction -b over 2a closed fraction. And we determine our axis of symmetry. So let's plug those numbers in. We have a equals -3, b equals 12, and c equals 11. Okay, so let's put those in. So opposite of b is 12. So we have x equals, open fraction, -12 over 2 times a. So that's 2 times -3. So our x equals a fraction, -12 over -6. Simplify, x equals 2. So our axis of symmetry falls at 2. Okay, but we know it's at 2, but what is our y value? So that'll really tell us our maximum. So we know our axis of symmetry, and so now we need to know the vertex, to know the y value. How high does this maximum parabola go? So again, we take that axis of symmetry value, 2, put it into our function, f of 2 equals -3 open, 2 closed, squared, plus 12 times 2 closed, plus 11. And when we solve this, we see f of 2 equals 23. So we have an ordered pair now at 2, 23. And we can say that the maximum value of this graph is 23. So the maximum value is 23. Okay, so that is the maximum. So the domain, so let's state the domain and range of the function. This is part C on page P11. So state the domain and range of our function. So the domain of the function is all real numbers, or R. The range of the function is all real numbers less than or equal to the maximum value of 23, or y is less than or equal to 23. Because of the parabola, it goes up, 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 up to 23, then it goes down, 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 down. So there's no values in this function greater than 23.